Okay, great. Well, I think we are ready to go. I'd like to thank everyone for joining us to today's webinar. It's being presented by Thoughtworks. We're a global consultancy solving complex problems with technology. We connect strategy and execution, helping clients to strengthen their core technology scale and flexibility to create seamless digital experiences. And today we're going to be talking about data mesh and domain ownership. I am your moderator, Sean Kaiser, and the lead data engineer on the data and AI service line here in Barcelona, Thoughtworks, Spain. And we also have Zhamak Degani, and she's the director of emerging technologies in Thoughtworks North America. She is also author of Data Mesh, Delivering Data-Driven Value at Scale. And there's a bonus. There is a code at the end so that you can get an early release version of this and start taking a look and diving in. We also have Danilo. He's an early reviewer of the book as well, and he is the head of data and AI services in Thoughtworks UK. Okay, some ground rules here. The chat is great, and absolutely continue chatting. However, if you do have a pressing question, the best way to do it is with the Q&A. And we will hold most of those questions for the end, and then we'll get through as many as possible. And also try to keep an eye on the chat as well. And yes, this will be recorded, and so we will provide you with a link at the end of the presentation. All right, I'll let you all kick it off.
Thank you so much, Sean. So we're going to spend a few minutes on defining what data mesh is. And I know many of you might be sick of hearing me saying that, but early days of a concept, I think definitions matter. What it is and what it isn't, it's important. So I'm just going to, if you allow me, take a few minutes defining data mesh. So data mesh is the definitions are hard. Its current definition is it's a socio-technical approach to sharing, accessing, and generally managing data that it's most useful for analytical use cases. It's most useful when you have to look at the data historically, or you have to see patterns in a large amount of data for training your machine learning, writing reports, visualizations, and so on, in environments that scale matters. So I want to just double click, what does the scale mean, and what does kind of analytical mean a little bit. So in the, let's say, as Danilo, if you can click, so you might say, early 2000s, we had the problem of volume, right? The volume of data suddenly with every business going digital and having these digital touch points for collecting information, we found ourselves with a large volume of data, and we had, distributed file systems, distributed data processing, the Hadoops, MapReduce, and so on to address that concern. Moving forward, we then noticed a variety, a scale in terms of different types of the data. So we were happy with structured, relationally designed data, and then we found ourselves, well, we get capturing voice, we're capturing messages, we're capturing unstructured data, and came the creation of the object storage and accessing data in different modes for different purposes. Moving forward, we had mobile in everybody's hand, and most of our interactions moved from kind of the desktop applications to mobiles, and we saw this velocity, a scale of velocity. So in terms of how rapidly the sensors, the mobiles, the events could get to organizations for processing, and with that we saw the birth of technologies like the streaming technologies like the Kafkas and the like. So what is left to deal with? And I think that the scale that data mesh tries to deal with is the scale of complexity, and particularly complexity on two different dimensions. The complexity of ubiquitous nature of the data, that data can come from anywhere within your bounds of organization, within the bounds of trust that you have, right? Within the customers, from the customers you directly interact with, or it can come from even outside of your organization. I mean, majority of a lot of the actually interesting analytical use cases of machine learning and pattern recognitions are happening where the data is coming both from inside and outside of the organization. We work with our ecosystem of partners, and they share data with us. So this nature of the data can come from anywhere, and it's constantly the complexity, the fact that it's constantly changing and morphing. There is no one definition of a particular concept. And also on the other side, our aspirations in terms of how we want to use the data is growing, and it's changing from, I have one or two machine learning models or statistical models deployed in some very specialized corner of my organization to, no, actually the design of every single product, every service, the logistics, the optimization of workforce, everything has embedded intelligence in it, and we need to have access to the data that lends itself to that style of processing. So it's a complexity that data mesh needs to deal, that tries to deal with, the scale of complexity. And then the next slide, please. And so what is analytical data? Danilo, sorry, you can go through all of the transitions on this slide. Right. Thank you. So what is analytical data? So first and foremost, I like to always start definitions through the lens of the consumer, through the lens of people who uses that data. And again, these definitions are not absolute. They're a bit fuzzy, so please accept that. In majority of the cases, in most of the cases, analytical data is the data that's used by your data scientists, by your data analysts, maybe even application developers that deal with data-intensive applications, but they're looking at training their machine learning models. They're looking at creating trends and dashboards and really gathering insights from the raw events that happen. That's a purpose of using analytical data. And then, that they do predictive analysis or diagnosis of problems. And if you look at the nature of analytical data, what it isn't is the transactional data that's keeping the current state of the business right now. It is all of the changes that's happened to the business over a course of time. And that course of time might be infinite, depending on your policies, how far back you want to go. It has to reflect the truthfulness of the business. So it's not some transformed data downstream. It's actually showing the events as they happened. Of course, we can transform them, aggregate them as well, but it has to have that business truthfulness built into it. It can come from, again, any corner, anywhere, any application, and it has the large scale, the nature of it, that's the intrinsic nature of it. So that's kind of the putting some boundaries around when we say analytical data, what we mean, and it doesn't mean transactional data, transactional databases. So where does it live today? Before data mesh, right? Before data mesh got introduced, and we can transition through the slides here quickly. This data on the operational data plane, we have our databases that running our applications. They are optimized for a particular microservice to do its job. It's not optimized for an analytical workload to run its large scale processing on it, and that's perfectly okay. So I have a retail application, I have an e-commerce application, and it has a database that keeps the current state of my shopping cart, keeps the current state of my session, and so on. And then on the other side of the organization, in the past, we said, well, if you actually want to see all of the changes that happened to the shopping carts of every single customer who logged in or didn't log into our website or connected to our website, we're going to get all of that information through some sort of a pipelining, or the modern twist of it, some sort of event streaming, and put it into a lake, a centralized storage of semi-structured data, or even better, we're going to model it into some sort of a multi-dimensional relational database of large warehouse, so that later on you can come and run those analytical works. So you can run your machine learning, train your machine learning model on all of the different shopping cart properties that you have seen over the course of time, so that you can make predictions that what products are selling, what products getting abandoned, why they're getting abandoned, and how can we change the behavior of the customer for the product don't get abandoned. So this model, and there's one more click on it, this model also relies on this bimodal operation at different teams, different domains, requires some sort of a central governance as well to allow us to make the data secure and compliant and so on in that centralized place. This model, and if you go to the next slide, has had these challenges, and that's why the data mesh came to exist, because it is hard to scale out as the number of sources grow when you have a centralized a labyrinth of pipelines and a centralized place to keep things and a centralized team to maintain that data. It's hard to scale when you have so many different use cases and you still try to represent one canonical view of your data. It's hard to bootstrap building big solutions. Ultimately, it's hard to materialize data-driven value. So what we've seen is that if you compare the the spending that we have on, let's say, infrastructure or mobile or other aspects of technology compared to the money we're spending on data, the return on that money and investment is actually lower in the data management space. So next slide, please. So this is the core of it, and it needs a couple of transformations quickly. At core, data mesh tries to address this problem. How can we build a model that doesn't have this centralized kind of blocker and can scale out as your organization grows, as your ambitions around how to use data grows? Next slide, please. And this is a pseudo graph that I've kind of created to just carry this point that we are at a pivotal moment, at a moment that if we follow just what we've done, as the approaches that we take into data management, as the complexity grows, we're going to see, and we did see a plateau in, are we getting value from data? As things change, are we still staying nimble and agile in responding to that change? Data mesh tries to take this pivotal moment as a default starting point. Say, this is reality. Let's work with the grain rather than against the grain. That world is complex, things are changing, organizations grow, and with that as a default position, what model can we apply to that data management, particularly for these growing use cases around ML and analytics? Next slide, please. So at core, it has 4 principles, and today we were going to double click into the first one, which is let's find the axis around which we can scale out modeling of data and access to data. And that's today, it looks like that axis is domains of the business, where action really happens, where data gets generated, or data gets used, and we will talk about that. Data as a product is the second principle, and it's really addressing the issues that can arise from the decentralized domain ownership. And it says treat data as a product, and it's a very simple phrase, but it has very deep consequences. And one of those consequences is that how we represent data, a domain-oriented data must satisfy the needs of data consumers, and you have a portfolio of data consumers. You don't have single data, you have data analysts, data scientists, and they access the data very differently. So that data needs to have this multimodal access and a certain affordances or characteristics that you can proudly say, this is a product. I am delighting the experience of those data users. We actually have a recording on data as a product on our website that you can go and reach out to and watch. And it talks about both from the product ownership and organization, as well as the architectural consequences of this principle. The last principle is that, well, how is that even possible? Do we need to go and hire an army of data engineers and data scientists and embed them into every domain? No. And the only way we can do that, we can create a career path for our generalist technologists or generalist experts technologists become data providers or data consumers, is to reimagining our data platforms and creating new sets of tools that satisfies, that doesn't have the complexity of tools that we deal with today. And we are seeing the evolution of those infrastructures. And we will have actually a talk on this one later in the year, I think in October. We can perhaps share the links to the talks in the chat for you. And then finally is that, okay, this is going to be madness, every domain running around modeling their own data, and no data will talk to any other data, and how do we know if things are secure? So the final pillar is really federated computational governance. So we'll have a talk on this on the 28th, I believe, or 4th of August. We will share the links. It's really rethinking the governance model that suits a decentralized world, a complex, ever-moving, ever-changing decentralized world. So let's next slide, please. If you just want to put this visually very quickly, you'll have your domains today. One more click. Your domains running microservices, running legacy applications, One more click, please. And they're generating data, but they're generating that data in their internal databases for their own usage, for how their API is constructed, for what they care about to run the business. They're not sharing the data for how analysts wants to kind of run analysis on it, or how a machine learning might be trained on it. They don't have any incentive really to do that. The best they do is expose events to go downstream somewhere in the lake or warehouse. So this model says, let's integrate these planes together through this concept of data as a product, as a collaborative quantum, an architectural quantum that sits right next to your microservice or applications and generates data for usage on the outside, and most importantly, structured in a way that satisfies those kind of large-scale queries and historical queries. And two quick clicks, please. And to make this possible, we have the platform and we have the governance, which will be a topic of a different talk. So let's make it a little bit more practical. Danilo, I pass to you. I know this is a very close topic to your heart, so let's dive into the domain-driven design.
Sure, thanks, Zhamak. Yeah, domain-driven design was kind of the main thing that got me hooked in data mesh when I saw one of Zhamak's early drafts for the first article. And I've been a big proponent, like building software systems and like the approach that Eric Evans wrote in the book about how to tackle complexity in software. And he was really trying to bridge this gap of like when we think about the technology or the software we're building as a separate thing from the language and the way that the business thinks about how that software is going to be used. But really, domain-driven design is about collaborating, people that understand the domain in the business with people that are building the software. So we reduce that kind of translation required. So some of the concepts I think was quite interesting, and they always in my head apply to data. And I think when Zhamak put together like the principles of data mesh, that kind of closed the gap in my own understanding as well. But things about like, let's use a ubiquitous language. Let's think about things within bounded context and how do different contexts relate to each other. So a lot of the techniques that I really liked from domain-driven design suddenly clicked how we could apply that into data. And that was one of my questions to you, Zhamak, like why does data mesh brought domain ownership into data?
Yeah, I mean, if you look at the objectives of data mesh, is that there are three really main objectives. Is that world is complex, it's volatile. If anybody had any doubt about it, 2020 really put that in our face. And things are certain. So how can we respond gracefully when things change? So we need a modeling approach that does that. Businesses are growing. That's just how the economy works today, unless we come up with a different model of economy. But businesses continuously growing and merging and acquiring. So how do we respond to that change? And how do we get value from the data? So if you just click, there's a bunch of transformations that data mesh introduces, and this is a long list, but a few of those are implemented through domain-driven design or domain, and I call it domain ownership because I wanted to emphasize on the fact that data needs to have owners from domains who are most familiar with that data, and those ownerships are long-term. They're not just that I'm a project owner and project is done, I'm gone. So the past blockers that stops us from making change quickly, stops us from responding to change, is this monolithic centralized bottleneck. So the domain-oriented aspect of data mesh tries to decouple that monolith in a way that business, technology, and data aligns, right? And we've had this already. We've had microservices really starting this revolution by aligning technology and teams with the business. We're just extending that, say, well, hey, like you can actually have data that is useful for, I mean, we already have data on the outside of microservices, and Rahul asked the question, like, what does that mean with operational data? We've already solved the problem of data on the outside for operational usage. Like I want to update the customer address. I have an API that I go and do that. And that happened with the alignment of technology with the domain. But we never address the problem of, actually, I want to see all of the changes that happen to this customer's address. I want to see the population of addresses that we have so I can make some decisions around the demographic of my users. I can train my machine learning about that. We didn't solve that problem. We just said, okay, for that, you need to go to the warehouse or the lake. So this is trying to kind of align that. again, if you want to really be respond to change very quickly, you've got to be as close as to the source as possible. So this lost business context and truthfulness through transformation pipelines, and I know I've started kind of a war on pipelines because it's a wonderful concept, but when you apply it at scale imposing this sort of transformations before the data can be used or be useful, you lose that truthfulness of the data. So it tries to, domain-oriented ownership again tries to close the gap between the operational data, the transactional data sitting in the database of my app microservice, and the data that I'm externally displaying, while close the gap, while respect the differences. There is a difference. I mean, run your analytical load on your operational database and your customers will be screaming at you. So unless we have a technology that satisfies both, and we don't have it today, at the logical level, we need to kind of separate this, but yet align them. There is lack of ownership. So that's domain ownership tries to bring the ownership to the domains. And then there is the synchronization, that synchronization problem that we have in our organizations without synchronized, centralized team. And again, domain ownership tries to say, is there a way to solve this problem with running workloads on a mesh of data products through a decentralized way, rather than running workloads on that is designed by one team in one kind of set of technology stack. So again, localizing change, removing synchronization points, and localizing change to domains where it happens with clear contracts and boundaries within those domains. So these are some of the transformations that are possible only with domain ownership, and not only, but domain ownership tries to solve this, kind of brings these enablers to satisfy the objectives, higher objectives.
Great. And then if we think about the other principles, like they don't exist in isolation. So how do you see them connecting to each other?
Yeah, so it's, I feel like I'm talking too much about this, but I think it's really important to understand the foundation. Domain ownership, as I said, like we really started with the problem of decomposition, and we said, okay, domain ownership. But the moment you do that, other problems arise, right? It's like, God, how am I going to stop people from siloing their data into their domains? And then we introduce the concept of actually data is a product that your domain will be incentivized for sure. And I know there is a question in the chat about how do we actually incentivize people, and we can talk about that certainly. You'll be incentivized and you will be accountable for sharing that data as a product, so we don't end up with just domain looking internally and hoarding their own data and be happily using their data when nobody else can use. Then the problem of how do I empower those domains to be able to share the data as a product, and how do I make sure that domains don't become isolated and we don't have this very frictionful communications when we need to talk to one domain to another domain, when we need to make sure that the things that need to be consistent across those domains, like how do we express the modeling language, how do we expose the data, how do we secure the data, those things can be implemented with computational governance within each domain. And finally, reduce the cost of ownership with the data platform, and make sure the things that need to be consistently implemented in every domain through that, somewhat centralized platform can be automatically embedded into every domain. And that's why we have 4 principles, not just one, even though we talk about the first one today. All right, so I think one of the questions that I often get asked is, how do we identify domains? Like this has been, I think that since the birth of DDD, it's been a question we've asked when we were designing microservices, and now we're asking them, how do I do that for data mesh? So Danilo, I would love for you to kind of give us some guidance on this. I know you've been in trenches doing this work for quite a while and interested in it.
Yeah, I'll try. I like to start with this quote because there's many ways you can model things, and like all the models are wrong, but some of them are useful. So that's kind of the mindset that I take when I'm thinking about this. There's no right or wrong question or answer. And even like people talk about like, oh, domain-driven design, we're just trying to model the real world. And I have an issue with that view because it's like, what aspects of the real world are we trying to model, right? Because like the same concept, sometimes depending what you're trying to do, you can represent them in different ways, and they're both right in that specific context. So just as a simple example here, like let's say these are the things that exist here. I could try to organize them to say like by shapes, maybe, then you will end up with a model that looks like this. Or maybe you're trying to do something that you're trying to organize by colors, and you end up with different way to organize the same concepts. And both are correct. You can't say that one or the other one is wrong. It really depends what you're trying to do. And with domain modeling, it's a similar thing. Like we take inspiration from the real world to understand like the language and the structures of how people communicate and how people interact with each other. But then we need to understand as well, like what are we trying to do? And what I really like about connecting to the other principles, right? Like when you're modeling a data product, you're thinking about the consumers and how people are going to use that. So when you're doing your modeling, you are already thinking about that, like what you're trying to do with it, not just trying to model something in a vacuum. And the other thing to realize is that the models evolve. I like this model from Eric Evans that he talks about this exploration whirlpool. We take scenarios from what our understanding of the business or the real world is as the kind of starting point. And then we come up with a model that we think will be able to answer the questions we have about that. And then we'll try to turn that into software somehow. So we're going to write some code, and especially like a lot of what they wrote in DDD literature is about aligning that language in the software itself to the language that we use when we're defining those scenarios and talking to the business and the domain practitioners. And sometimes by writing code, we find edge cases that either we find new scenarios or we find edge corners about the models that are not working. So this thing is really iterative, and like they all feed into each other. By writing software, we'll understand a little bit more what we're trying to do. That will inspire us to come up with new scenarios, and that will feed into like our models, and we will have to refine those models with time. The other thing to think about is that domains exist within domains as well. So we can think about like, oh, as a retailer, retail is a domain. But maybe the way you operate as a retailer, like, oh, there's a whole supply chain for how you get a product to your customers. And then there's a domain for how you sell that to your customers. And you might organize that way. So those are valid domain boundaries as well within the bigger retail. And you can break it down even further, like in selling, maybe I need to manage the ordering, what customers are buying, the pricing that I am offering them for products, and even like just capturing the transactions as they're happening. So there's a bunch of other potential subdomains within that space. And then there'll be subdomains within the supply chain as well. Like you need to, sometimes you have to produce stuff, make things, or source them from somewhere. And then you have to manage distribution and how you move things around, logistics. So like there's all these aspects that the boundaries of the domains can exist within each other. And then in terms of like answering the question, how do we get to the right modeling? When we work with clients on this, we always start this journey thinking from the value. Because again, we're trying to understand what are you trying to do with the data? What's the ultimate value you're trying to get for? And define these data opportunities or use cases. They'll usually cut across domains. And then from those, really articulate like, okay, how are we going to get value from this? How do we break it down? Which one is more important? Which one is less important? And then we take that as inspiration to say, okay, if we want to deliver this journey, what are the data products that we need? What domains are we going to need to touch for delivering this journey? And even like to build the self-serve infrastructure. I saw a question there, how do we do that? We're not going to build that all at once if we're starting from scratch. So we can identify what are the key capabilities that I will need to start to support this journey. And we'll do this for a few of them. So like we're not trying to build a fit for purpose thing just for answering one value case. But if you've got a good coverage of value cases that cover different aspects of your organization, that will give you a good starting point to finding those early domains. And it doesn't stop here, obviously. We take that into like, okay, how does that turn into a roadmap, and how does that help me build out the platform and evolve this over a period of time? So when we engage with clients trying to do this, we go through this kind of process, but it starts with understanding really the value and what we're trying to do.
Can I just on that one, Danilo, maybe one point to clarify is that I identifying your domains from the value is really important when you, particularly when you're doing an iterative implementation. And we will always encourage an iterative implementation so that you go through this process many times, right? Until you, I mean, there is no end to end really. Every time you come up with new use cases and then you discover your domains or you refine your domains and so on. But you've got to be careful with that so that you don't end up actually just using the use cases in a way that you end up building a bunch of point solutions, because ultimately your goal has to be, well, I want to satisfy these use cases, but yet build a platform and yet build a set of domain-oriented data products that satisfy this use case and a bunch of others. So you have to have this two-pronged approach of use the use case to know where to get started, so you don't have to boil the whole ocean. But while you look at have this other prong which looks at your current business and current domains that exist, and look at and say, okay, what data do we need to surface up as data products from these domains for this use case? And next time we do a different one and a different one. But having that data product owner who thinks about not only this use case, but also all the other use cases that might be coming down the pipe. So they have the, looking long term while implementing through iterations for immediate use cases, right? So, and we have a lot of challenges with our clients because sometimes, is it like quickly build a data product for this particular use case and you lose sight of, and you have to go and refactor that again, lose sight of it. So there's a delicate balance between use cases as a vehicle for execution versus just build a point solution for one or two use cases.
Yeah. And there was a question as well, like how do we validate that the boundaries are right, or how do we know that how can we evaluate if we're doing it, moving in the right direction?
Yeah, you never know, and they're never correct. They're just an approximation that are good enough today. I think it's going back again, this absolute mindset that some of us have, that is, it has to be correct. I mean, what does even correct mean? It means that it's optimized. It's an approximation of a possible, in the possible, space of modeling that is useful today and perhaps may not be useful tomorrow. So that's why what's really important is ability to change, not so much to get it right. Having said that, that was a bit of a smart answer, but let's embrace that as a reality and then say, okay, I still need a set of heuristics, a bunch of litmus tests that says what I have today is good enough, right? It's a good starting point. It's a good place to be. And I think this is a space that I hope that collectively as an industry, we can build more of and create more of these heuristics, but there's a few of them. So does, the boundary that you have identified lend itself to long-term ownership, right? So as an example, if in retail, I have a business function that is designing these shirts, right? By the way, I've got my new swag from Thoughtworks. I'm wearing it today, which we've rebranded ourselves, so showing off a little bit. But if this shirt in the design domain, we know that design domain will be designing our products on a seasonal basis or annual basis, and these designs will have long-term ownership. There's a design function within the business. So that seems like a long-term ownership is baked into the business. So it's not a project, it's a product, it's a function of the business. So then it seems like a good boundary to start then looking at what data can we expose from this boundary. So that's one. And there might be domains that come to exist that it feels like nobody's an owner of them. There was a question there. And if it's really, really important for you to create those domains, well, create a long-term ownership for it. Can you actually create new owners and long-term ownership? And those domains might be aggregate domains of getting data from multiple places. The second one is what we already talked about. I mean, look at your business and see if you can reflect that, right? If your model is in conflict with how your business functions and how your business has decoupled itself and organizes teams and it organizes metrics and KPIs, it's probably, maybe theoretically is a beautiful model, but it's not a good model for you, because that's not how your business breaks itself, decomposes itself. So we want to, again, don't work against the grain, work with the grain. So, and the last one is, you will be exposing multiple data sets from these domains when we call these data products. And again, there's a talk on data products, what the data product is. So let's say from the sourcing domain, you're exposing bill of material for the different designs that you have. So that bill of material has its own life cycle independent of the production of that, the production of putting those bill of material together and create SKUs. So, so look at the, again, object-oriented design. We've done this for decades now. High cohesion, loose coupling, same life cycle. Data changes based on the life cycle of that particular entity. And that can still, and why we do that? We do that because, going back to the beginning, localizing change. If you have organized your data that 50 different, touch points can change that data, and we have to synchronize all of these changes, unrelated changes, perhaps, and also at the same time, the cognitive load of figuring out all of these changes and make them possible, keep the data consistent. If system seems complicated, perhaps we need to simplify it. Perhaps we put too much into one, or the other way, you can be too granular. And again, one change can cascade across 50 different pieces. It's not that 50 changes changing the data, it's that one change needs to reflect like many other different places. So maybe there is. So it's just as Danilo said, it's an iterative process, and these are some litmus tests, and I hope we can create more of those. And I know, Danilo, you talked about we talked about domains, right? But the next question always is, how do I structure my teams? How do I structure my data products? Can I have multiple teams for a domain? Like, how does the reality of actually mapping domains to teams and data products look like?
Yeah. Well, there's a natural kind of split that we think in terms of data products belonging to a given domain. And usually the domain will have many data products, but maybe it has just one, that's fine as well. And the data products can be used within this own domain, but oftentimes you get value when it's used outside of the domain that's originating it. And we talk a lot about like the different types of data products. Some of them might be more source aligned, some of them more consumer aligned, or you might have some fit for purpose data products in the middle where you aggregate data and then you make that available as a valuable data product on its own. So it's quite important to think about this. They don't operate in isolation. The real benefit of mesh is when you start connecting these data products. So that's one axis. And then the teams, how do the teams come into play here? The teams will own one or more data products. And it really depends on the complexity. So I'll talk a little bit later about how we can assess and do the litmus tests for how we break that up and who owns what. But they will usually sit within a domain. And as Zhamak says, they will have a long-term ownership for those data products, and understanding that long-term vision and how it can enable many consumers is what they're going to be doing. We do get questions sometimes like, oh, can the team own multiple domains? Yes, if it makes sense, if it fits in their head. Like, it's not at scale, right? When we're talking about the complexity growing, that might become too much for a team to manage. But maybe when you're bootstrapping and you don't have like that much data products yet and you're just starting, sure, the team can start and build things across domains. But what we like to say is, because the data product is the architectural quantum for the what you're building, even if you do that, you would want them to exist as separate things. So like as you grow later on, if you decide that you need to hand that over to a team to actually own that domain and those data products, that's easier to do. And then, of course, there's also the teams around the self-serve infrastructure. So we've been talking a lot about the data products themselves, but there will be teams building those shared and like domain agnostic capabilities that the data product teams will be using. And to operate the self-serve infrastructure as well. Maybe they write some shared components that make it easier for the teams to develop their data products. and thinking about the platform itself as a product. So you will have one or multiple teams, depending how complex and how big the capabilities you are exposing. One way that I really like to think about how you manage and how you evolve these ownership boundaries is using techniques from team topologies. So they talk about like the different types of teams and how they interact with each other, but also taking the lens of like cognitive load. So how much does the team need to understand in their head to be able to function? And if the cognitive load gets really high, then it's too much for that team to manage. That could be a good indication that you can split the ownership a little bit and have multiple teams owning different parts of it. But also thinking about the flow of value. So what are they delivering as value to the rest of the organization? So just as an example here, using the team topology kind of terminology, you might have the self-serve platform team offering the platform as a service. You have those stream-aligned teams, which are your data product teams on the domains. You might have maybe like some complicated subsystem, either in the platform or in one of the data products that you do need to have a specialist team with specialist skills to do that, and they collaborate with the wider team. And you might have those enabling teams as well, usually helping from the platform team to the data product teams, how they can leverage those common tooling or the common platform. So they might facilitate them for a while and get the team up to speed with some particular set of tools, and then they move on. So applying this kind of lens to how you think about the team boundaries and how much they own and how this evolves over time, it's a quite useful technique.
And that one, Danilo, maybe just, this is it's a very simple but very useful diagram, and we love the work from folks that would work on team topologies. Is if you zoom in reality, if you zoom into that self-serve platform team itself, there's not one platform team. In fact, you break down, and this is what we had to do, like there's no other way. You break down that platform capabilities also around domains of platform. Like you might have, okay, I'm working on a team that's providing the ability to provision data products autonomously. I have a team that's working on discoverability. I have a team that's working on, the knowledge graph of the mesh. So there's just might be actually many different teams, and they are stream teams that are providing capabilities within that platform team. But from the perspective of like global organization, you can kind of simplify with this diagram and say, okay, I have one platform team.
That takes us to the master data management.
Yeah, so this one is a little bit of an elephant in the room, right? So we often get asked, folks that have been in this space for a long time, how about master data management? So maybe we just unpack what that master data management is. I love to use the definitions from DOMA, kind of a nonprofit organization that has been, international organization has been around, and they've done an amazing work. There's an amazing body of work in their book, on kind of all of the concerns around data management. And there are really good intentions and objectives behind it. And we're not really challenging here why we need to do it or what it is. What we are suggesting is a different approach. So what is it? I think what's master data to start with. So we recognize that in our organizations, regardless of these domains that we talked about that we're in, logistics, shipment, sourcing, design, there are certain entities, there are certain concepts that are shared, that they really matter to run the business, and they matter to not just one domain, to every domain. So this concept might be employees, products, vendors, customers, right? They are shared concepts. So we call the DAO folks call this master data. So these are these core entities. And the objective of master data management is that for the business as a whole, globally, to reduce risk of having inconsistent information, to reduce, having duplicate copy of the data around that represent the same concept, but in an inconsistent way because it's been copied and never updated. We need to have a system that provides this shared concepts as master data in an accurate form that shows the current values with consistent identifiers and consistent information globally across the organization. And I think nobody will challenge that this is a bad idea. I think this is a very noble set of, these are noble kind of objectives to have. But I want Danilo to talk about reality, because you've been in trenches and you have seen approaches to implement kind of master data management and how difficult and complex it can get in reality. So
yeah, so let me talk about this example. Is probably familiar, like people, even if you haven't worked in this industry, it's quite easy to understand. But the concept of product is a common entity that's subjected to master data management. Product is something that will have a long life cycle across the entire retail domain. Like Zhamak said, it will be touched all the way from conception to when you're selling it or retiring it. And it will have similarities in other industries. So like if you're in pharma, maybe like your product is the medicine that you're trying to develop. So there will be kind of parallels with other industries as well. In this particular case, Zhamak and I, we both work with a client that is retailer, but in the clothing space, fashion retailer. And if we look at the way that like the business people are organized and the language that they use, we will hear like everyone talk about the products. Some people call them items, some people might call them a style. But if we're like talking to the designers, maybe they will think about this as the product. What is the product for them? It's more like the concept and the colors and things like that. In the sourcing domain, maybe you care about the bill of materials. So like, what do you need to actually make this product or to buy this product from someone else? In logistics, maybe you're talking about packages and shipments and parcels because you're moving the product around. Distribution, you're storing it, so you're keeping track of where it is in a warehouse. And then maybe when you're selling, you might have variations, or you might have photos about the product. So there's lots of across multiple domains products. It's a key consideration. But if we zoom in, like the actual concepts and the attributes that we need to understand about the product in each of these domains are actually quite different. So when we, as I said, in the design space, you may care about the color palettes, fabrics, flavors, if you're building like a edible product instead of a piece of clothing. In the sourcing domain, I need to understand the suppliers that can offer things, the bill of material, what cost am I paying to buy this, the size of the product, maybe now I need to understand. And then in logistics, it's more about the packaging. If I'm shipping things internationally, then I need to care about customs codes and does it have any hazardous material that I need to declare? I care about the dimensions, the weights, and things like that. In distribution, I care about the inventory that I'm keeping, if it's going to expire or not. Do I need any special storage conditions to keep this? T-shirts is probably fine, but like if I'm a grocery retailer, then maybe you get things that need to be in a fridge or things that will expire or go off. And then in the selling domain, again, I need to know the price. Do I have stock available for this product to actually sell it? Which channel am I going to sell this on? So there's lots of different attributes and different concepts. They all relate around the product, but they're quite different. And the approach usually taken from master data management is quite like a centralized approach. So it's let's build a master entity to aggregate all these disparate views so that we create this single view of the product. So we will get all these different characteristics of the products and we're going to bring that into the master product. So if you want to know anything about product, you can just get it from the master product. And that tends to be problematic in practice. We see data quality remaining a problem. And despite these goals being valuable and good intentions, a lot of these initiatives fail. And they tend to become quite large because you can imagine you will touch across the entire organization to try to make sense or come up with a model of the product that suits all these different usages. So some of the common symptoms and problems I've seen. One problem is, oh, it's master data management, then I need to buy a master data management solution. And as you can imagine, you can't solve that with just a technical solution. It's way more about how you're going to use that, how the people, the processes interact with that data that can cause data quality and ownership issues. So you don't solve all these master data management concerns just by buying a solution. From the user perspective, oh, great, now there's one more place to get that data, right? Do I go to the source or do I get it from here? The other problem we see is a lot of these initiatives, we acknowledge there is quality issues, and then as part of creating that consolidated view, then we're gonna fix quality problems. But that tends to mean we fix it downstream and not at the source. So it can propagate confusion about the data quality, and long-term it can create more problems. Because as a user now, I'm gonna start asking, like, why is it different? Which one is the correct one? Is it this one or the other one? The other problem we see, it tends to be very centralized approach. So we're gonna come up with like one model to rule them all. And that tends to make that model really large and really complex. And funny enough, it's usually not fit for purpose and harder to understand, because if you're trying to bring all of those things together, then it might not serve the purpose. So the user might see, like, I don't understand, like, why do you need me to put this attribute here? This doesn't make sense to me. And it still doesn't fit my need. Like, I need maybe product data in a different shape or in a different format. There's all this other noise here that I don't really need. And then the last one is large big bang in terms of the approach. So you tend to require a lot of coordination across the organization to get these things in place. And then it creates some mistrust from the user. So they might say, I've heard about this for a while and it's been going on, but I worried about it when it's live because I'm still gonna keep using what I'm using now. So if we go back to this picture here, by trying to do this, you create that coupling and forcing some of the synchronization. So when things change in any of those domains, you need to make sure it will flow into the master domain. And you still have those people living in the domains and having those localized contextual understanding. And then we create another team now that will try to create the global understanding. That's not the teams that are on those domains. So you're trying to fix it outside of the source. And then when the users come to use, they will get confused because now you still have data living within the domains. And you also have a master data product that you're trying to make people use. So that's kind of some of the problems I've seen. And it's really hard to create that single view of products, mostly because if you really try to do it, it's going to be too complex to represent in a single model. You're way better off having different models for different usages. And domain-driven design actually encourages that. It doesn't force you to have just one model. You can have multiple models, and you can show how the models link together. If you're trying to create one single view, you will force the data to be at the most granular level for everything, which might not be the most optimal way to use it, because if you have to answer any potential question, then I can't aggregate the data because then I'm going to lose some of that fidelity. So it forces you to keep that data at the most granular, even if you're not using that data at that level. And it also forces this single representation and shape. I like to think about the shape of data. If I need to think about product data as a graph, for instance, and you're forcing me a master product as a relational data, still doesn't fit my purpose, and I'm going to have to transform it. And funny enough, what I think is it creates data quality issues sometimes, because, for instance, we force people to think about a distribution attributes when they're creating the product in the design space. So they'll be like, okay, this is just an idea, but this I'm registering the product in the system, and I need to ask, I don't know, how much weight does it have, or does it have any special custom codes that I need to set? And what people will do is like, this doesn't make sense. I'll just put empty or no or not applicable, and you start creating a lot of these data quality issues early on that propagates through the rest of the life cycle later on. So Zhamak, how does data mesh help here, please?
Yeah, so I have to start with a caveat to say, these are kind of at the principle level. These are some of the principles we want to apply. There is no standard or that yet has been created that said, this is a standard we're going to follow in terms of modeling the data. And I really, really hope these standards will emerge. So next time we talk, like, you know, in a year or two, there is to say, oh, you know, you use this modeling standard and that's how you do it. But the data mesh approach, instead of collecting, imagine this is a transformation that needs to happen. Imagine instead of collecting that data from all of those sources, instead of creating a model that represents data from all of those sources, so at the modeling and the data level, instead of collecting, you want to come up with a model that allows connectivity of the data and yet allow localized definition of those models. So multiple models connected, multiple sources of the data as data products, but yet relatable and linkable to each other. So that's the goal that we want to get to. And these are just some of the things we need to incorporate into our data products. So the very first one is that we need to have, for data to become a data product, so for that design, in the design system, like maybe you're using a legacy design system that internally generates internal IDs for the design. But for that design becomes a data product and data on the outside, we need to have a globally unique design ID that now, when we talk about a particular design, regardless of you're talking about in the design domain or outside of the design domain, we're talking about the same style, right? So global identifiers that allows this kind of federation of queries or federation of, connectivity of the data, I think non-negotiable, right? You may say that, in fact, there is more than just the ID that we need to make consistent and all agree upon, and maybe you want to go down that route, but you might say, actually, there is an overlap between the definition of the style in the design phase or design domain and definition of the style in the sourcing domain. And those overlaps, we may need to standardize those. Data mesh doesn't say yes or no, it's just minimize things that you need to standardize. And at a very, very, very minimum, you need to standardize your IDs, right? ID system. And I've gone through, in fact, with that particular domain, this is not a new problem. Like if you have implemented microservices in your organization, you have already solved this problem. So this particular retailer we worked with, actually, they had a very kind of make microservices approach, domain-driven design of their organization, and they already had to solve this kind of product identifiers, like how do we define our identifier of products that can be referenced regardless of what domain, looking at what attributes of it. So that's number one, the globally addressable identifiers. The second one is the semantic definition, the modeling of the data for a domain. And again, I don't know if I talked about this in the data product talk or not, but I think I have actually. You want to have a way to semantically model your data for your domain, regardless of how syntactically it gets encoded, right? So you may want to encode your data in JSON or Parquet files. You may want to encode it as SQL schemas or other modes, or all of those, in fact, because you have multiple customers. But semantically, you have to have a syntax agnostic way of modeling your data for your data product. Those semantic models should allow linking of entities, linking of those models to other domains, right? Or sharing kind of parts of the definition. So having linking of the semantic enabled in your language of choice, in however you do your semantic modeling. And I wish there was one that I say, hey guys, let's go and choose this standard for our semantic modeling because it ticks all of these boxes. It's simple, machine understandable, human understandable, has linking embedded. There is no such a standard. There are kind of pseudo standards that people have used in particular domains where they have spent a lot of time trying to do domain modeling, like the fire domain has a structured definition. But there is no W3C standard, let's say, that I can point you to that I would say fit this. So I really hope that these things will evolve. And lastly, the data linking, right? So you have with those unique IDs, with those globally addressable IDs, you can also link the data from one domain to another domain if you need to. One thing to remember though, this is not a distributed transactional database. I want to re-emphasize this. We're not talking about your transactional databases. We're talking about a snapshot of the data at a point in time, so that because we're talking about a read-only snapshot of the data at a point in time, that's a definition of a data product. And if you haven't listened to that talk, please go ahead and do so. If things change, if a new style gets, let's say we have a new style generated in the design because we're going to the next season, but we haven't yet produced those design, or we haven't made that design externally available, maybe our data product has the set of style IDs that was representative of the state of the world yesterday, but it hasn't yet been refreshed or added, more information have been added to it from our design microservice or design legacy system to represent the style. So the next time data product will publish its data, and it's always a bitemporal data. So today we have processed all of our styles, and this is the representation of the styles today. Then we will see those new IDs. And then when that goes into production, that data kind of cascades, the updates cascades to, I shouldn't say updates really, that those new point in time data that got added would cascade to the other domains. So please do not take this as this is a transactional database that needs to have a global consistent information. You will have a global eventual consistent state through time-stamped read-only information. So I know that some of you might be thinking otherwise at this point. So what does it look like? Yeah, so my photos, let's say in my selling, I want to have a catalog of my photos, so videos of this style. I might be referring to that global addressable style ID. It's the same style that was designed in the distribution. When I'm thinking about the stocks, I'll be using the globally addressable SKU ID that perhaps the leader that first generated it was the SKUs domain, but everybody else can use the same ID and mean the same thing. They may add their own attributes to it in their domains, or they may just use the attributes defined in the production domain. So what you end up is a mesh, right? Is a mesh that has multiple linkages, multiple types of linkages. So one linkage would be the flow of the data lineage, and this linkage is the linkage of the semantic and the linkage of the data itself. So you have really 3 layers of mesh that when you look at a data mesh.
I just want to call out the discoverability on the side there, because once you're in this mode, then the question is, how do I find, like, what's the definition of which one should I use? So building that discoverability affordance in the data products, that you can have a place so you can find these things and really understand what each data product offers, is what helps users to decide which one they need.
Yes, absolutely. I mean, it's with that's the infrastructure layer, right? The mesh, we call it the mesh experience plane, which are a set of capabilities that allow you to operate at the mesh level, not at a single domain level. And this sort of interconnectivity of this graph is a mesh level concern. So you should be able to discover what is relevant to you, not the source of truth or one model to rule them all, but the piece of the model that is related to the use case that you have, and be able to compose them if you need to.
Yeah. Cool. That takes us to the end. Zhamak,
all right. I'm glad we had 1.5 hours for this conference, and I've already been told to speak a bit more slowly. But we love you guys, and we want to share as much as we can. So we give you a lot of information and talk really fast. So sorry, I'm going to go quick on this. Why we need data mesh? We need to have a dimension, an axis of decomposition around the dimension that scales with you the growth of your organization. So this is not for a small startup. This data mesh is not for a small organization that has very few maybe domains. It's just trying to understand its market fit and place in the world. Data mesh is really for complex environments, have seen many acquisitions, many mergers. They have grown. They're complex, hairy environments. So and they're growing, or is a scale up that is growing, and they're feeling the pain of that maybe warehouse and lake, and they're slowing down, and everybody's unhappy. If you're in that state, why? Well, we'll try this. What it is really at core tries to align business, technology, and data that satisfies those very difficult cases of access to data in terms of machine learning analytics with the long-term ownership of domains, how you go about it. It's an iterative evolutionary approach. In fact, there were a few questions around domains, like how many subdomains should I have, and how many, the data products should I have. There is a talk, again, available on Thoughtworks website, Dave Calls and I did, around evolutionary approach to building your data mesh, and we introduced a bunch of kind of KPIs that you can track over time to see, and one of those is lead time to creation of new database, lead time to discovery and users of a data product, and track those. If those numbers going away from what you wanted to go, well, maybe change needs to happen. And finally, I noticed a bunch of talks were happening, next slide please, around kind of, is this a lake? Is this a functional lake? Where do the domains need to fit? And it isn't a functional lake. It's not a centralized team. And this is really about the transfer. This slide's going to make you uncomfortable intentionally, and that's good. It is about the change of mind that needs to happen. We're not talking about flowing data from one place to another so that you can get value. Is that data is valuable right at the source, and you can consume it right there from a different source, combine it together if you need to. We're not talking about one canonical model or no model in the case of many of the lake ones. We're talking about multiple models connected. The source of truth, this holy grail that we've been chasing forever and ever. Maybe we need to revisit that assumption that we need to just find the most relevant domain. If you talk about, go back to that data product, each of the talk that I had, each of these domains are reliable. Each of them have an SLO and a quality metric that are guaranteeing, and that's a big departure from the lake mentality, that you have owners in those domains that are responsible for the quality. So that copying problem goes away, that the data that I can't trust hopefully goes away. Pipelines, we didn't show you any pipelines, but if you paid very, very close attention, we had put 3 little lines inside the hexagon icon of a data product, and that's what it meant. It meant that any logic, any smart logic that needs to transform the data will happen as an implementation details in the context of the data product, and there are strict contracts around that data product in terms of the schema and the data itself that hide that complexity of the pipeline, so we don't have any smarts happening between the data products. The smarts get hidden as implementation in the data products, and data products has a computational context. It's not just about data, it's about data in its computational context. And again, we talked about a way to decompose your architecture at a macro level that is around business domains, not around technology. It's not about, I'm going to dump it into the event stream, and then I'm going to dump it into the lake, and then I'm going to dump it into the lakeshore marts. If you have an architecture, solution architecture that looks like that, you have designed your architecture around technology and not really what matters, which is the data itself and the business reflection of your business. And I think that's where we're going to leave you. If you want to learn more, there's this book. I promised you a code. So if you use that code, hopefully you get at least a month of free access to O'Reilly platform. I know folks at Starburst also have sponsors, so you can go to their website. Thank you.
Amazing.
Well, we had 1 hour and a half as well.
Oh, me too. It's such good stuff, and there's so many good questions. I don't think we'll get to them all, but I'll start in the order which we received. I have some really good questions from the chat that I just kind of curated and tried to combine a few. So hopefully we'll get to some of those, and I'll just go back and forth. The first one from Raul. Does it mean that data mesh is predominantly focused on data from an analytics point of view and not focused on operational data used for standard reporting? How should companies manage the data from a mesh point of view when the ERP platforms start deploying analytics capability as part of the ERP, such as doing part of the analytics on the ERP platform, such as the data does not come to the lake, but is locked in the vendor's data models?
Yeah, so there were so many points packed in that question. So let me just pull the threads apart. I think there was perhaps a slight misunderstanding around operational and analytical. The moment you said standard reporting on operational data, I just thought maybe we're talking about 2 separate things. So I promise you, I'm working on the next early release to really unpack this operational analytical, because it has come up quite a bit recently. So what I meant by operational, really what I meant was transactional data, right? It's a database that needs to be transactionally immediately updated when you register a new customer, right? When you get a new call center call. So is the data inside of your applications that have a very transactional nature? And also the data that your microservices or your ERP system is exposing as a set of, again, I call them operational API, because their main purpose is to run the operation of that business unit, to answer calls of that customer's support. So in main intention and design of that database is running the operation of the business. So that's the operational analytical. It's not a bimodal binary thing. It is a continuum, and there was always going to be fuzzy services that, or fuzzy sets of data that fits. Is this analytical? Is this operational? Maybe both. So it's not really a binary. Data mesh doesn't focus on how do I design my microservices API? How do I design my GraphQL API that tells me for this particular customer, what is his address right now? I mean, we've designed that, there are APIs to do that. What it tries to do is to extend those APIs, extend those services. That's why it's domain oriented. It's the same team that's working on, your ERP system. Extend those with a view of the data that has the characteristics that in most of the cases, the training of machine learning model as well as reporting requires. And that characteristics means that this is a temporal data. This is both events as well as aggregates. I mean, events are great for showing the very fine-grained changes, but they're not really great for majority of the machine learning model training we have, or even reporting. So if you find yourself you need to, again, move this data to a warehouse before you can do anything useful and a useful report on it, data mesh tries to bring that closer to the source. So it's the extension of the APIs for most of the cases, analytical use cases, that you look at the data over the course of a long period of time. Then you mentioned ERPs. So unfortunately, many of the SaaS products, they want to control all of your domains in one application. So the domain DDD gets thrown out the window very quickly when you have one of those, like, I'm going to do it all for you applications. Even though they may internally have applied some DDD, but they may not externally have it exposed. It is everything's so interconnected that you can't have these clear APIs. Our recommendation, which is the same as what we did with microservices, is having these kind of anti-corruption services or layers on top of your ERP. Again, this is read-only data, so data only pushed out. This is not a transactional system to update the data. So that have this kind of anti-corruption services that exposes at least the domain-oriented view of that ERP system, and then off the back of that, build your data products that represents that read-only kind of aggregate view of your data, all of the changes that are happening over time, right? So the ERP doesn't necessarily, for doing its daily function, needs to show you every log of change that happened, or how the customers are sharing, or all of the customers in one API. And that's really the job of those the adjacent data products for that. But it's very hard to really apply DDD when you're using those products, and they're very, very much everywhere, like everyone's using them. So those anti-corruption layers are needed.
Okay, excellent. I got another one from Nazia. How do you keep the decoupling for the data mesh from turning into a massive cost increase in every area? New headcount, new databases, etc.
Yeah, that's a good question. I would challenge the cost, because we have very simplistic view of the cost often that only counts the capex of we bought this and we have that many people. And the cost doesn't account for opportunity losses, that how many opportunities we missed, how much value we missed to generate to offset the cost that we are incurring. So the cost of missed opportunities are not calculated. So I would encourage everyone to take a more holistic view of the cost, and that includes kind of opportunity into that. I do agree that we are creating a world that requires decoupling some of those centralized teams and redirecting our workforce where it should be applied. But I also say that the reason we have a new new self-serve infrastructure, which goes beyond your databases, which goes beyond your, workflow management systems or job processing. The reason we have that pillar is actually abstracting complexity so that you can upskill, cross-skill the workforce you have today to build data products. So making this assumption that you have to go and get new headcount, I would challenge that. So yes, you may have to inject the roles that you had centrally into domain teams as that enablement team that Danilo showed. So there's a restructuring, a reconfiguration that needs to happen. You will very likely use the existing technologies that you are using, but you will reconfigure them in a different way. So if you're using an object store, you will continue to use that object store for your data mesh. It doesn't mean that you're not using it, you're just reconfiguring it so that the tenancy model and the account ownership model is decentralized and reconfigured. But there would be a point, perhaps a transitional point in time that those tools don't allow that sort of, I'm going to use the same object store that I've been using it, but I'm going to define the account structure, ownership structure, so that they're independent of each other. So there might be a point in time that Amazon might be, I don't know, or Azure or whoever is providing your object store charge you more for that because their charging model hasn't thought about this multi-tenancy or distribution. And let's not say multi-tenancy, it's a distribution of object store or usage of object store in a distributed fashion. And hopefully the providers will catch up and change their charge model to cater for that. But there were some really hard assumptions in that questions that I would say we need to revisit. Having multiple databases, perhaps not. It's the same object store, it's just we configure it differently. Having additional headcounts, perhaps not. Your product owner that manages the call center application for the call center can extend her or his responsibilities to provide that data externally, but she or he needs to be empowered with the right tools to do it.
Yeah, I just wanted to highlight two things on this topic. One around the self-serve infrastructure, because we get that question a lot in terms of like, oh, now every team is going to have to build and maintain their own infrastructure. That's going to cost a lot more. And that's why we have the principle around self-serve infrastructure and the platform team, like Zhamak said, like you don't need a database for everyone. So that's one thing we'll probably address in the webinar when we deep dive into that principle. The other one was when we talk about aligning the business and the tech and the data. If you think about domains, the teams building your operational systems and the domain should align with the data product teams as well. So it's not like, yeah, you're going to build a whole nother organization outside of what you have. And I've seen some of the questions about like, oh, you need a data steward on the other side. But to me, like always we talk about data steward, it should be that the people already exist, I think, in your organization that understands that data. It's just that extra bit of responsibility that we need to help them to make their data more valuable and more usable for the rest of the organization.
Okay, excellent. All right, let's move on to the next one. One challenge to be addressed before distributed data ownership can be adopted widely appears to me to be, how do we incentivize, monetize it for participants providing data? May be associated with compute for scaffolding. Often data ownership may not always be with those who generate it either. So what would be the contours of governance here?
It's a really good question. And there were two questions jam-packed into one question. We catch you when you do that. Yes. So let's address the first one. If you ask me today, what will make data mesh fail? It won't be that we won't have the right infrastructure. We won't have the right people to do it. We won't have the technology. That will catch up. We are brilliant engineers. We have brilliant engineers to solve that problem. The thing that will make it break is not embracing the cultural transformation that needs to happen, not empowering or enabling and expecting responsibility of domains to provide data. And to me, that feels like the biggest, I don't know, the hypocrisy that we're facing today. We've got, mission statements all over our walls or virtual walls that we want to be data oriented and data driven and all of those good things. And yet, when we talk about ownership of the data, it's a hot potato that we want to pass to someone else. right? So, and it's just, it's not as simple as we don't want to. Sometimes we don't have the education. We don't know what is even possible using data. So it's education is a big part of that. Sometimes we don't have the accountability structure. And as you said, initially, I feel I'm not an organizational change person. I'm sure you in your organizations, if you have the scale that want to deal with data mesh, you probably have people who think about empathy and motivations and Maslow's hierarchy of needs and all of those things to really motivate people. But I feel like initially what we have at least seen is that organizations manufacture these artificial incentives, like we report to the board how many data products we have or how many data products are being used in our use cases, what strategic incentives are using the data on the mesh, and so on. So these are just artificial strategic incentives to add to your OKRs or KPIs that you have. But ultimately, to me, I feel like this will crack the incentivization, not just with money and chargeback compute, and those things are great and they have to be at a mechanical level implemented. But the only thing we will have empathy, will create empathy within domains to serve the data, is that every domain becomes intelligently empowered and actually needs data. Like once we figure out how to use data for decision making at every point of touch point with our customers, and every product that we sell, or every the service that we serve our clients, have ML and analytics and some sort of data-driven decision making embedded to it, we have the empathy for access to data, and then we won't externalize that to somebody else. So it's a really good question. We have to start with some manufactured API KPIs, and then hopefully, from top down, from the CEO down, we'll embrace intelligence embedded into every function.
Yeah, absolutely. Yes, 100%. Okay, I got one last one I think we can do. I saw several questions around governance, so I'm going to throw this one out there. How is this federated computational governance implemented? So maybe just elaborate a little bit on what that looks like. And I emphasize federated, I would say.
Yeah, I just want to say, come on, I think this is 24th of August to 28th of August. Come later in August to talk about it. We'll have a veteran data governance person who's been like a data governance person for decades. And with novices like myself, battling this out. But I just point out two little pieces, like why, if I could inject another word in that phrase, I would have called it embedded federated computational governance. But it's like three pieces to it. One is the governance decisions are not decisions that you again externalize to centralized third party. The people who are tasked with governance. It's actually a decision-making body federated from the domain owners. So domain owners have a stake in the decisions and also accountability for applying those decisions to their domains, like how we're going to define the privacy levels of our data. And the computational part of it is, for it to be real, it has to be computational. We can't just define things manually and enforce them with carrots and sticks. We have to be able, in a Turing complete or incomplete way, describe these policies as computational policies and then have platform embed them everywhere. I mean, this has happened already. This is nothing novel. We have zero trust architecture, right? To embed policies into every endpoint and access point and computation and enforce them. So that's a computational piece. And embedded, we just talked about embedded, right? So you want to be able to enforce these policies right at the right point at the right time, at the time that data products built, deployed, or accessed. And that's really the job of the platform to do that. Anything I missed, Danilo, you want to say?
No, you covered it all. I thought it was a good question as a segue because we'll have the next webinar specifically diving into this topic. Yeah. So well done, Sean.
I'm very excited. Yeah, this is one of my favorite topics right now, so I'm pretty eager for that.
Great.
Okay, wonderful. Well, I'd like to thank everyone for coming. And you've been a great audience. Really good questions. So many we didn't have time to answer. A lot of them, but thank you for attending. And yes, don't forget. We will be distributing the slides and the recordings, and at the last slide, there is a link to download the book, the data mesh book, right? The book on data mesh things, all things data mesh. And yeah, thank you so much.
Thanks, everyone.
Thank you.
Thanks for everyone. And the 125 that stayed to the last minute of the 90
troopers.
minutes. Take care.
Thank you.